International Renewable Energy Workshop of Mardin University. It is organized by Mardin University. I am Dr. Abdul Fattah Abdullah Shobolli from Istanbul Sabahattin Zaim University. I am the coordinator of this session. This session is about scientific developments in renewable energy. We have 4 speakers. The first speaker will be Dr. Sunil Kumar, Associate Professor, Mechanical Engineer from Iran, University of St. Zanjan. The second speaker will be Dr. Jose Andres Gomez Romero from Mexico. He is from CFE Corporate. He is a specialist on hydroelectric projects. The third speaker is Dr. Muhammad Wali from Istanbul Sabahattin Zaim University. He will talk about reliability of power systems in the smart grid. The fourth speaker is Dr. Samet Öztürk. He's from Bursa Technical University. He will talk about offshore wind energy and some case studies related with that. The fifth speaker is Dr. Sunil Kumar from India. I may have some difficulty in reading the university name, but BT Sindri Davant, maybe, sorry if I just misspelled the university name. He's going to discuss about solar energy. This workshop is about renewable energy, and it was very successful. Today it started, and so many invited guests, non-professors, discussed so many topics so far. It will continue for 3 days, and I just looked to some of the programs, and a lot of interesting topics from wind energy, from solar energy, from biomass, and so many renewable energy topics are discussed so far, and it's going to be discussed also further tomorrow. And some of the topics are specifically about the case studies, about the financial issues related with renewable energy, about the technological solutions. I hope our today's session will be also very nice, and we are going to get a lot of interesting knowledge and ideas from professors, doctors, which are invited today. And the followers of this session, after each session, after each discussion of the guest, you can forward your questions, we can discuss further, and we can exchange valuable informations and knowledge. So if everyone is ready, I don't know whether Dr. Sunil is available now. Maybe let me check. I cannot see Dr. Sunil. Is he around? Okay. Everybody, can you hear me, please? Respected guests, professors. Okay.
Dear Abdullah, I just want to make a point here, because they live in other countries. Sometimes they might have some connection problems or problems with accession to the internet. We can start. I think they will maybe pop in later.
Yeah, we can start from the next.
Yeah, from the next speaker, please.
The next speaker will be, sorry for the programs. Dr. Romero, is he around, please?
No, I don't think so. He's not joining yet.
Okay, so we can start from Dr. Muhammad Wadi.
Yeah, by the way, I want to welcome Mr. Samet Öztürk. Good evening.
Good evening, thank you.
Good.
Okay.
If you are around, who is the last participant? I didn't get.
Thank you very much for invitation. Let me to start.
Okay, you can continue, Dr. Muhammad Wadi. First, you can introduce yourself and you can continue the discussion.
Yes, I'm trying to share my PowerPoint. Yes, okay. Hello, everybody. This is Mohammed Wadi from Istanbul Sabahattin Zain University, Department of Electrical and Electronics Engineering. My presentation today will be about important issues while assessing wind power potential. My presentation will cover those topics. It will be as introduction, materials, and methodology. I will talk about also distribution functions and optimization methods. We will talk about the numerical estimation methods, as well as I have to talk about some statistical descriptors and accuracy measures. We will have case study here in Istanbul, and we will talk partially about the result and discussions. Finally, we have a conclusion and recommendations. As we know, wind energy is one of the most rapidly growing renewable energies worldwide due to the many advantages it offers. Wind speed distribution for particular site, figure out the available wind potential. Once the distribution of wind pattern is established, the wind energy potential can be specified. So wind energy availability allows investors and developers to collect more accurate visibility of the site under study. The process consists of several steps. However, wind regime characterization via distribution functions, one of the most critical steps. So, determining wind regime distribution pattern is essential for several reasons, such as estimating wind resources, planning wind farms, visibility studies, wind turbine design, and long-term investment decisions. Therefore, selecting conventional distribution functions for describing wind speed frequency distribution accurately is a crucial mission. In this respect, Weibull, Gamma, and Rayleigh distributions are the most widely used distributions for modeling wind speed distribution. However, they may not be the best for modeling all wind regimes. Consequently, alternative distributions are required to be studied. This study represents a comprehensive analysis based on different distribution functions, optimization methods, and the numerical estimation methods to describe the wind speed distribution. Like following, we have 18 distribution functions, also 10 optimization methods. We have also 7 numerical estimation methods, as well as we have 7 statistical descriptors, 5 accuracy measures, and finally we have the net fitness test or error measure. The distribution functions studied here in this study, like Rayleigh, Poisson, Weibull, normal, Gamma, Laplace, log normal, Nakagami, Bernoulli, Sanders, Bohr, as well as we have extreme value, inverse Gaussian, logistic, log logistic, half normal, generalized Pareto, generalized extreme value, and T-location scale. As well as the optimization method that are used to carry out this study, like genetic algorithm, particle swarm optimization, Gray-Wolf optimization, Cross-Huber optimization algorithm, and the modified one, moth flame optimization, multiverse optimization, Salb swarm optimization, and whale optimization algorithms. However, the numerical estimation methods are graphical method of moment, energy pattern factor method, mean standard deviation method, power density method, maximum likelihood method, and the modified version of maximum likelihood method. To carry out this study and to perform the needed comparison, the hourly collected data from Chattal gestation for 3 years are analyzed, and the wind speed data are extrapolated and studied and at 3 different heights, 30, 60, and 80 meters. Here we are talking about the process of estimating the parameters of distribution. The parameter selection of a distribution can be considered as a nonlinear optimization task by which we can minimize the mean absolute error between the measured and the predicted wind speed vectors mathematically as shown here. Here I give some examples for Weibull distribution function. Here we have the probability density function, and here the accumulative density function, and here the inverse accumulative density function. Also, we have here the flowchart of genetic algorithms because the study is very huge and we have a lot of things. Only here I have some examples. Also here we have a gray-wolf optimization method as well as whale optimization algorithm. The data, since the results are very huge to present here, I'm going to present some parts of these results. By investigating the tables here, we can see instead of mean and instead of average power, we can see gamma distribution based on genetic algorithm provide the best matching of the real data at 3 heights. However, the same data set, but based on particle swarm optimization, we can see that Weibull and Bohr distributions provide the best matching to the real data. Those are instead of mean and average power. But to do, in order to accurately compare the performance of different distribution or something called goodness of fit, we here have 5 major errors, and we have net fitness to give us the final decision, which one is the best distribution and which the estimation method is the best between those methods. So, based on those parameters, the analysis of 2008 dataset based on genetic algorithms, we can see gamma also distribution in terms of all major errors provided the best matching to the real data. So as shown here, the rank of gamma is 111, the first rank. However, for the same data based on particle swarm optimization, we can see Bohr and Weibull have the first and the second rank respectively. Although the gamma distribution achieved the best based on genetic algorithm, it cannot, based on particle swarm optimization, was not able to approach solution as shown here in table. Here we can see Riley achieve the best goodness of fit based on a grasshopper optimization algorithm as well as salt swarm optimization. On the other hand, we can see Weibull based on a gray-wolf optimization, moth film optimization, and whale optimization algorithms was the best. Here, Weibull computation time. Also, we have to take the time into consideration here because the time is very important to do a good comparison. Here, Weibull computation time is about 2 to 3 times when we compare with Rayleigh distribution. On the other hand, we can see here inverse Gaussian distribution have the worst or the highest time between all of them. So these issues should be taken into consideration during assessing. Although here another table for elapsed time, although normal here distribution was the best instead of computation time, however, it was poor in terms of goodness of fit. Here, I have a part of result based on numerical methods. Based on a numerical estimation method for the same data, 2008 data set, at 30-meter height, we can see energy pattern factor have the best good of fit, while power density have the best at 60 and 80 meters. Graphically, from the PDFs plots, we can notice that most of distribution functions can achieve matching with real data, but with different degree of accuracy. On the other hand, some of distribution, as can see from here, either provide poor matching or completely different match, such as Laplace and Poisson distributions. In this section, I will talk about the important issues that deduced from this study. First of all, one of the most critical findings is that the distribution pattern of one regime differs from one location to another. Therefore, different distribution functions should be used to accurately determine the wind distribution pattern. In other words, a particular distribution can provide the best matching at a particular site, but not at another. The second important finding is the selection of optimization method, or in general estimation method, which depends on the characteristic of wind speed data, computation complexity, and convergence. For instance, gamma distribution based on genetic algorithm achieve the best matching, while Bohr distribution based on particle swarm optimization did. Consequently, the trade-off between various optimization methods is an indispensable requisite. The third important finding is the used error measures. For instance, a certain error measure may achieve the best for a particular distribution, but the worst for another. Thus, it is necessary to apply different error measures. Then, to determine the top rank estimation method accurately, the net fitness computation is required. Thank you very much for listening.
Dr. Muhammad Wali, thank you for a very nice presentation. You have discussed a lot of issues in relation with wind energy forecasting. Dear respected guests, or maybe the audience, maybe the question and answer session is directly now or after everyone is finished. Maybe Ahmed Boz, you can recommend me.
Well, if you have got any question right now, you can just forward. But if you don't have it, maybe some of the audience will ask it at the end of the session.
Okay. Yeah. If no one is going to ask, maybe I can ask one question to Dr. Muhammad Wali. You have discussed some of the fitting methods and some of the forecasting methods. You took some data from energy, from the wind energy somewhere around Istanbul. What type of data is that? Wind speed, or what are those data? And another thing I want to ask you is, you are forecasting for what? For which years, for example? You took some data, and are you modeling some way of formulas to forecast for the future, or what is your main intention there? And have you tried also machine learning mechanisms to just teach some machine about those data and maybe use it for the for future forecasting, and how you are going to use those forecasts, or the huge investment, or for what purpose? Thank you.
Okay, thank you very much. We have a data for 3 years collected from Çalıştayı site, and we collected this data. We obtained this data from Istanbul Meteorology. The study here is to make describing or specifying the wind pattern. So up on this collected data, we can specify the wind speed pattern at that site. Here we use a lot of methods to accurately specify the pattern, because when you specify the pattern speed of wind accurately, you can at the same time specify the potential energy accurately. We have a lot of optimization methods and numerical methods. Those methods are using to find or estimate the optimal values of the parameters for each distribution. And up on those parameters, we can estimate the wind speed. And after that, we can, up on the whole pattern, specify the wind potential at that site. This data used only to show the comparison here, but those methods can be used for any site worldwide. Okay, thank you.
Okay. Can I ask a question, Mr. Mohammed?
Yes, yes, please.
You know, when generating energy from the wind power, is there any specification for a best place to build up this kind of system?
I didn't get your question. Please, okay. Can you?
So, I mean, to generate energy from wind power, are there any criteria to choose the best place? Near mountains or on the other platforms?
Yes, yes. Thank you very much. This is a very nice, very good question. Yes, there is a criteria to a lot of things to study in order to select the particular site or the best site for wind energy potential or wind energy generating. This study, one of these things, maybe the best or the most important one, is how to specify or describe the wind speed pattern. So according to those results, you can take a decision if the site is good for generating wind energy or not. So in this presentation, I only have some parts of the results because there is a lot of results. For example, I gave the mean value. The mean value is very important indicators to say if the site is good for generating wind energy or not. At the same time, I talk about the power density. Also, the power density is very important indicators to specify if the site is good or not for power generators.
Thank you, sir.
Do you have any other question, please? Maybe last question for you, Dr. Mohammed. Was the wind data you used was minute data or hourly data or yearly data? What type of data it is? And also your model is going to forecast for what type of data, hourly, yearly, or what is the duration of?
Yes, very, very nice question. The data, the collected data are hourly data. So we have about 8,760 hours for each year. And the study here is up on 3 years. So the data are hourly data. And the forecasting system or modeling system based on each hour. So the optimization method is established here or proposed to do this study, doing minimization, mean absolute error between the predicted value and the measured value. So we try to minimize the value, the error between those two speeds in order to find the best values of parameters for each distribution function.
Okay, thank you, Dr. Mohammed, for your nice discussion. And the next presenter is, I think, Dr. Samet Öztürk.
Excuse me, Mr. Abdel, we have a new participant, Mr. Ibrahim Faulan, and we want to welcome him.
Okay, welcome.
Good night, good morning, good evening to everybody.
Thank you very much. Welcome. Is he going to be the next presenter, Mr. Ahmed?
You just can keep going with the next, no problem.
Okay, he's an attendant. Okay, thank you. So Dr. Samet Öztürk, you can continue your presentation.
Okay, thank you very much. Let me share my screen first.
Please, if you introduce yourself, it will be very nice. First.
Sure. I think you can see this. You can see my screen, right?
Yeah, it's clear, teacher.
Okay. Hello, everyone, and dear participants, dear audience. I'm very happy to be at this very nice workshop today. My name is Samet Öztürk. I work at Bursa Technical University in the Department of Environmental Engineering. So my topic today will be on offshore wind energy, and I'll talk about some case studies regarding this. In the first part, I'll talk about some background information, such as explaining wind energy, offshore and onshore differences, and then offshore wind energy installation globally. So wind energy, as you all are familiar, it's a renewable energy type. The wind is always here, and therefore it's called as a renewable energy. And it's a clean energy source. Clean means in the life cycle of the wind energy system, there is a relatively lower CO2 emissions comparing to the other energy sources. And it has relatively, again, lower levelized cost of electricity among other energy resources. And it has around 20 to 25 years of lifetime. Here you see a nice typical wind turbine. We have 3 blades, and we have a hub to connect these blades. And then we have a gearbox here to increase the rotation of the blade rotation. And we have a generator to generate electricity. Then we put the generated electricity into the grid. And here we see the types of wind energy or wind energy systems, I would say, based on the locations of the turbines. We have onshore types and offshore types. in the onshore types on the left, you see the wind turbine is located on the land. Its advantages can be said in three here. I listed three. They are cheaper than the offshore ones. Their installation is easier comparing to the offshore. And the maintenance, operations and maintenance are easier on the onshore wind farms. However, there are advantages on the offshore for the offshore wind farms as well. So we have higher energy yield because of the higher wind speed on the offshore wind farms. We have more stable wind on the seas or oceans, and we don't consider the lands or limited land on the offshore wind farms. Therefore, these can be counted as advantages of the offshore wind farms. So for offshore wind farms, they differentiate from onshores based on their foundations. On the left, you see different types of foundations, but they are stable ones. And these are called fixed bottom offshore wind farms. And on the right, you see floating offshore wind turbines. So the difference is based on basically the depth of the sea. If the depth of the sea is less than 50 meters, the tendency is to use fixed bottom offshore wind turbines. And if the depth is more than 50 meters, they use floating turbines. Now, here you see a graph of showing levelized cost of electricity of several different energy resources. Here we see the offshore wind as in the side of lower levelized cost of electricity, comparing to the nuclear, the fuel cell, rooftop solar PVs, and geothermal and coal. And you can see the lowest levelized cost of electricity. We see the land-based wind, which means onshore wind farms. Here we can say that the offshore wind is like investable or profitable. At least we can say it has a lower levelized cost of electricity. When we talk about the environmental parts of the offshore wind, in this graph, we see that the energy indicator and carbon indicator in terms of among the energy resources. Energy indicator means energy consumed during the lifetime of the system per generated electricity. And we see that offshore wind farms have 41 watt-hour per kilowatt-hour electricity generated. For carbon indicator, we see that the wind energies have much lower CO2 emissions per generated electricity than the conventional ones. As you can see here, offshore wind farms, for example, 16 gram CO2 per kilowatt hour, whereas the coal-fired power plants have more than 1,000 grams CO2 per kilowatt hour. In this sense, we can say that offshore wind farms are very environmentally friendly in terms of the greenhouse gas emissions. Some environmental drawbacks of the offshore wind farms are listed here. The first is the visual impact. Basically, people tend to run away from offshore wind turbines to not to see on the shores aesthetically. The second impact is the noise impact. It could cause acoustic disturbance for the fish habitat in the sea. And military bases can be affected nearby the shore. Bird baths, this is even for onshore turbines is an important environmental concern. And the ship collisions are the other environmental concerns for the offshore wind farms. Here we see the graph of installations of offshore wind farms by year. And we can see that the global offshore wind energy installation is around 30 gigawatts as of 2020. And 3 major countries contribute to this. United Kingdom is the leader of the offshore wind energy in the world, with more than 10 gigawatts of installation. Germany is following UK with 7.7 gigawatt, and China is the third one. So I'm going to mention about these 3 countries, and lastly I'll talk about our country, Turkey, in terms of the offshore wind power. So for the UK case, you see the global wind atlas here. The shores of UK has lots of wind actually. So you see more around 10 meters per second at 100 meters height wind speed around the shores of UK. This is a very good actually advantage for the country. They put a 15% renewable target for 2020. This was another motivation for the offshore installation. Another motivation was that the land scarcity, because they limited the land scarcity limited the onshore wind deployment. And the great wind potential, I already mentioned about that, and the shallow shore of the UK seas. These are all the these all contributed the offshore deployment in the UK. And you see the UK offshore wind farm map here. And I listed some of the biggest wind farms here on the UK shores. Actually, Hornsea 1 wind farm is the biggest wind farm, offshore wind farm on the world. Now it's more than 1 gigawatt capacity. And Walney is also more than 1 gigawatt capacity. And so there are also some of the under construction offshore wind farms. So UK is constantly increasing the deployment of offshore wind for themselves. So for German case, we see again the high increase in the deployment of offshore wind farms, more than 7 gigawatts as of 2019. And the motivation again was a national target. 35% renewable energy by 2020 was the national target, and this is already exceeded actually. They already overachieved. Now, as of 2020, the renewable energy is 46% for Germany, and they actually renewed their target to 65% by 2030 in the country. And this is achieved by actually the feed-in tariffs. Feed-in tariff means the guaranteed selling price for the generated electricity. For Germany, we see the offshore wind deployments on the Baltic Sea and North Sea. Mostly on the North Sea, there are even upcoming offshore wind farms here. And I again listed some of the biggest capacity offshore wind farms on German shores. For the Chinese case, again, we are talking about a national target, 50% renewable by 2050, and 5 gigawatts specifically for offshore wind capacity. They couldn't realize it on 2015, but now around 7 gigawatts cumulative installation of offshore winds is in China. But this is important, this point is important, that as of 2020, the total under constructed offshore wind farms are more than the actual wind capacity than the rest of the world combined in China. So they are coming very strong, we could say. And I have put some maps from Chinese shores for the offshore wind. They have mostly on the east side of the country, so right now, but they are on the northeast, they are putting more offshore wind farms. Sorry, this is actually automatically passing the other slide. I'm very sorry about that. I couldn't control that. And the Chinese couldn't achieve their target because of the risk that scared the investors. And as you remember, this increase, this was achieved by the feed-in tariff, the guaranteed selling price, but this is not going to be valid after 2021 as of now. And this was the case for China. And now Turkey, as of now, in the country, there is no offshore wind farm installation at the time. However, we have 65% renewable and domestic energy by 2023. And a World Bank report shows around 70 gigawatts of offshore wind potential on the country's shores. As you can see, there are very high wind speeds on the shores of the country. There were two bids in 2018 and 2020, but not finalized. And the Ministry of Energy already determined 3 areas for the placement of the offshore wind farms. And these are waiting for the investors for potential offshore wind farms on the country. So how the successful offshore wind countries make this, because they put some national targets, and offshore wind was one of the ways to reach these targets. And they put some incentives and feed-in tariffs. And for Turkey, we have a great potential to benefit. And there are 3 seas and 1 inside sea on the country's shores. And we have, for Turkey, there is a very high know-how from onshore wind energy. So using all these benefits, Turkey could deploy offshore wind farm in the near future, hopefully. Thank you very much for listening to me.
Thank you, Dr. Samet, for very nice presentation on offshore and onshore wind farms. I will just pass the chance to the followers of this session. If you have any question for Dr. Samet.
Can I ask a question, Mr. Abdul Fattah?
Okay, please, Dr. Ahmed.
Mr. Dr. Samet, first of all, I would like to thank you very much for this interesting presentation. Well, the question is, I was just wondering whether are those wind turbines good or bad for the climate? It's important for human life. And secondly, what attracted my attention actually, are those wind turbines harmful for birds or bats that are flying? Are we jeopardizing their life, or is it totally safe?
Okay, thank you very much. This is very good. These are very good questions actually, and also very debatable questions regarding the wind energy. The first question regarding the emissions, actually, there are many studies how they impact on the greenhouse reduction, and the studies, scientific studies, show that the wind energy, both onshore and offshore wind energy in the life cycle analysis, they give very little CO2 emissions comparing to the other energy sources, especially for the with the conventional sources. So we can clearly say that the wind energy is at least a good choice to reduce the greenhouse gas emissions on the atmosphere. For the second question, of course, the wind turbines are known as having environmental impacts on, or like killing impacts on the birds and the bats. So there are ways to reduce these impacts. I would say eliminate even these impacts. So the bird migration paths are known, and there are many studies again on this issue. So year by year, the effect on the birds and bats, I believe, it is also being minimal year by year.
Okay, thank you. If you have another question, please.
Yes,
thank you very much. Yeah, sir.
Okay, Dr. Mohammed.
Yes, I have a couple of questions. The first one, which is the best in terms of cost, offshore or onshore system? The second question, what is the meaning of the term feed-in tariff?
Sure. Thank you very much, Dr. Mohammed, for questions. In terms of the cost, onshore wind turbines are definitely lower, having lower, as you can see here, levelized cost of electricity. Levelized cost of electricity means per electricity generation, what is the cost? So as you can see here, land-based wind energy, which is onshore wind energy, is $54 per megawatt hour electricity production, whereas I'm talking about the maximum. The offshore is almost double, more than double actually. So why offshore wind is having more cost? Because of the O&M increases, because of their foundation types, they are more costly. The installation is costlier than the onshore wind farm. That's why offshore is having more cost than the onshore. The second question, the feed-in tariff is basically in order to increase the deployment of renewable energy, the governments make the investors, how do I say, make the investors invest on the renewable energy by giving them the guarantees 10 years or 12 years purchase guarantee. So basically they say that with 10 cents of kilowatt hour, I will purchase your electricity generation. So this is called as feed-in tariff. So in Germany, for example, I have put in Germany, they put 12 years of 15.4 cents per kilowatt hour feed-in tariff. And this is a very big kind of incentive to direct the investors on the wind energy.
Yes, thank you.
No problem.
Okay, if you have another question, please. If no one is going to ask, maybe I will have some questions. Actually, I worked in onshore wind farms, in the installation process of onshore wind farms, but not about offshore. I don't have much information, so what you provide is very nice. But you only discussed about the installation of the turbines and the foundations. And as much as wind farm is concerned, there are so many other infrastructures, like, for example, unit transformers, underground cables, maybe substations. If, for example, these offshore wind farms are very far from the shore, how these infrastructures are going to be installed inside the offshore, okay? Maybe what are the difficulties in relation with that? Maybe is there any other technical challenge with transportation of electricity from offshore to the shore? Thank you.
Yeah, thank you, Dr. Abdul Fettah. This is also a very good question. Because of these challenges, actually, the floating wind turbines are more costlier than the fixed bottom offshore wind turbines. The deployment of floating ones are very little on the globe right now. But in terms of the challenges, I believe the infrastructures such as cabling, such as you said, the corrosion, protection from the corrosion of the floating infrastructure of the turbine. These could be, or operation and maintenance of the floating ones. These could be very big concerns. As I said, this is, I believe that the floating ones are not much as of now on the world. I don't have exact number or installation in my mind right now, but by the technology develops, I believe the floating would be deployed more because countries would need this energy. For Turkey, for example, I mentioned about 12 gigawatt of fixed, but 57 gigawatt potential beyond 50 meters depth of the sea. So you need to solve these infrastructure problems of floating to achieve or benefit more from offshore wind energy.
Okay, thank you, Dr. Samit.
No problem.
Is there any other question from the house? I think there is no any other question. Can we have another presentation? I think both the guys from East and the West, one is maybe sleeping, the other is not wake up. So I think we'll finalize our session. Maybe Mr. Dr. Ahmed, if you have another recommendation.
Yeah, we have a new participant who came later, Mr. Professor Ibrahim Holdwand. Yeah, your microphone is off, and we would like to see his presentation as well.
Okay, good.
Okay.
The microphone is on, and can you hear me?
Yes.
Yeah, we hear you very well. Please go
okay,
ahead.
Good. Is it my turn to give my short presentation?
Exactly, yeah. Go ahead.
All right, thank you very much. First of all, I would like to thank all the colleagues in Mardin University who organized this stimulating event, and I am very happy to see that in one of my countries, neighboring countries, Turkey, there is a high interest in energy. Let me first introduce myself. I'm a physicist actually, and maybe it's 2 or 3 years that I have been attracted to solar thermal energy. So as a secondary activity in my research, I'm now doing research in concentrated solar power. And my talk is very short, and I would like to introduce you some aspects and some R&D activities that have been done in Iran during the maybe last 10 years. So let me prepare my talk. So I should share my desktop, I think. Let me, I don't know how to do it, sorry.
There is share screen just at the bottom. Yeah.
Yes, but I just lost it. I can see you, but
just at the bottom, maybe you have to minimize or maximize your screen.
Yes, I minimize the workshop button, but I don't know how to maximize it.
Sometimes
so just a moment.
Maybe you can try to double click on it, please.
There's a sign in, but I have already signed in. Okay, right. Now I'm in the screen. So I can see the share screen. I clicked on it and okay.
Yes.
So can you see the slide?
Yeah.
Yes.
Good. Okay.
See it very well.
Actually, yes. I'm a non-formal representative of Iran in Solar Pace's network of researchers. So let me briefly introduce what Solar Paces is. Solar Paces is an international research network, and PACES stands for Solar Power and Chemical Energy Systems. It's a subunit of IEA, International Energy Agency, and there are annual conferences. There is one annual conferences each year held in different countries, and every 6 months we have executive meeting. So most of the countries who are very active in renewable energy, especially in solar energy, are member of this organization. And in fact, I prepared a short introduction of Iran concentrated solar power activities, and I will give this talk in this meeting. I am from University of Zanjan. Zanjan here is somewhere between Tehran and Tabriz, and also I am a part-time researcher in IPM, Institute for Research in Fundamental Science in Tehran. So the first slide shows you the solar potential in Iran, and you see especially in southern area near Persian Gulf and southeast, we have very good DNI, direct normal irradiance. And I just tell you the R&D and commercial activities in solar energy that has been done in Iran. Unfortunately, we don't have any commercial plant, but there are some institutes and research centers that have done, I think, reasonable activities. We have two incomplete plants, one in Shiraz, you see here, and the other one is Yaz, which is in center of Iran here. The main activity goes in Shiraz, and they were going to build a 250 kilowatt parabolic power plant. It was going to be finished in 2014, but it was left incomplete. And I show you some pictures of the parabolic troughs. By a parabolic trough, we need these solar collector instruments, a very long collectors with the shape of parabola, and they can track the sun in one axis, and when the sun solar irradiation is irradiated on the surface of these reflectors, they will concentrate on a line, so they are considered as a line focus system. So these are some views of the solar collectors in Shiraz. They have collector fields, and there is a storage section here. And after installation of the mirrors, the solar collectors, linear troughs are here, and there are some heat exchangers, and these are some specifications you see of the performance. Unfortunately, this plant hasn't been completed, and the main reason is that they believe, the authorities in energy sector of energy ministry believe that this is not economic, and if they want to complete this plant, the price that they should pay is more than constructing a new photovoltaic plant. So the general policy, or the current policy, is that CSP is not economic, and the country is not investing, unfortunately, on this renewable solar energy. So this is another view of Shiraz plant, and some characteristics of the pressure and temperature. And the other point that the plant wasn't complete was that due to the international sanctions on my country, the ministry couldn't purchase the generator, and that was another reason that this project was delayed for some years. Another project was started in Yaz, and this is a hybrid power plant, and they intended to build and construct a solar field for pre-warming of the heat needed for this plant, but due to the reason that I told you, they haven't completed the plant yet. But I heard from some people in the Ministry of Power and Energy that they are going to complete this project. So you see here a picture of the main plant and the solar collector field. So beside these two, let's say, big projects, there are other projects. The Shiraz University, who was responsible for the design and construction of Shiraz plant, has recently designed a big parabolic trough. You see some pictures of this trough. So the technology of designing and constructing long parabolic troughs of say, let's say 100 meters is now available in Iran, but it is not economic. So maybe in the neighboring countries can use this technology. And here you see a picture of a 100-meter collector, which consists of 8 modules, each with 12 meters in length. And here you see some other characteristics. And the other research center, which has done some R&D in solar chemical energy, is this institute, Iranian Research Organization for Science and Technology. It's near Tehran, and they have done a small project, and the aim is to use the concentrated heat on the line focus of a solar parabolic trough to produce hydrogen by some chemical reactions. So they managed to produce hydrogen by concentrated heat of around 300 Celsius. There is another university called Yasuj University, and there's a group of people in chemical engineering. They have conducted research on a parabolic dish. And you see, this is a dish, and there is a 2-axis tracker here and a receiver. And when the dish is aligned towards the direct sun irradiation, the concentrated heat will gather at the focal area of the dish, and you place a receiver here, and you receive this heat, and then you can transfer it to the other place and exchange it. So you see some pictures of the receivers that has been designed and fabricated in Yasuj University. The diameter of this dish is nearly 2 meters, and here you see some other pictures of the concentrated heat, which is here in the focal area. And the other activity is taking place, it's not yet complete, in NRI, or Nehru Research Institute. It is associated to the Ministry of Power and Energy. It's in Tehran, and they are constructing a parabolic dish with I think 55 square meter. So this is not complete, but the structure is complete now. And the next stage is to put the reflectors facet or mirror facet here, and then the tracking system is also complete here, and the motor will be installed here, and the motor can absorb the heat and transfer it to electricity. This is called sorry, I've forgotten the name of this motor, but here you see some pictures of this parabolic dish. A Stirling motor. So this project is in progress, and you see some preliminary tests of the concentration, and this concentration has been. You see the focal spot that has been formed by installing of a few mirror facets, and the concentration is overall good. The picture has been taken by thermal cameras, and I think that the last project is the project of Iranian solar furnace, and this is in fact supported. This is a joint project between Iran and China, and it is supported both by Iranian Science Foundation and the Chinese Academy of Science. A 5 kilowatt solar furnace is going to be built in Iran, and a larger one, which is 20 kilowatt, is now being constructed in Beijing, in Beijing. And I myself is the conductor of the principal investigator of this project. And by a solar furnace, I mean a dish, but the dish is not is fixed actually. In contrary to this parabolic dish, which tracks itself towards the sun. The dish in a solar furnace project, the dish is fixed, but a set of heliostats will conduct the light to the dish, and the concentrated power will be concentrated on the focal area. And here you see the progress that we did for construction of the facets of this dish. And we did some experimental tests, CMM tests, for measuring the roughness of the surface accuracy of the facet surfaces. And then we glue thin mirrors on this, and then we'll install them on the main dish. Here you see a part of the facet, and here you see the surface accuracy tests, and here you see a single facet test when the mirror is glued, and a set of these facets will form the main dish. And you see here some concentration tests in my institute. These are my colleagues. And the last pictures that I want to show you is a solar park, which is near Tehran, maybe 100 kilometers away from Tehran. Let's say 15 years ago, there was a huge interest in Iran for solar thermal activities, and the Ministry of Energy made this nice solar park. It's in Talegan area, which is a nice area near Tehran. And in this park, they wanted to build and construct the various technologies of solar thermal energy. For example, here you see a linear Fresnel instrument. Here you see a large parabolic trough, and these are on the left, on the right corner, bottom right. You see some instruments for agricultural purposes or implementation of solar energy for agriculture. And in this area, in this picture, sorry, you see a large heliostat which can direct the sunlight onto the target. So in the summary, I can tell you that despite Iran has a very good DNI, or direct normal irradiance, however, unfortunately, there is not much interest to use this solar energy. There are some reasons. One of them is that we have abundant natural gas resources, and the gas is very, very cheap in Iran. So the solar energy, or to my opinion, all the types of renewable energy cannot compete. And second is due to the international sanctions, that the cost of implementation of any type of renewable energy is so high that the government wouldn't like to spend on these renewable energy technologies. But But I hope that in future the situation changes and we can utilize the great sunlight potential in Iran. Sorry, this was so short, but I'm not a very experienced researcher in solar thermal energy. I'm just a newcomer to the field, and I hope that I've been able to give you a quick overview of the CSP activities in Iran. Maybe we can do some joint project if you like in India, in Turkey, in other neighboring countries, and I hope that we can initiate international collaborations. Thank you very much for listening to my talk.
Thank you very much, Professor Ibrahim, for very nice and interesting outlook of solar thermal energy. Really, I appreciate all the efforts made, all the research activities, and all the innovative ideas. I think Iran is not in tropical region, so actually I will just maybe put as a question, but I appreciate really what was done, and I was not expecting even the sector of solar thermal energy as much as what you have discussed and explained in depth. I think there is also a very good potential in solar thermal, especially if we move all these works maybe to the tropical region where there is very high potential of solar radiation, high intensity. In most parts of the world, the focus is only on solar PV systems. And I think there is also very nice advantage potentials of this solar thermal. And I will give chance to the participants. If you have any question, please to the Professor Ibrahim.
Okay.
Excuse me, can I ask a question, Mr. Abdullah Fatah?
Yeah, please.
Mr. Abdullah, I want to thank you very much for this informative presentation. Well, what was interesting, as you mentioned in your presentation, in Iran, this is not really much demanded because you have an alternative energy, natural gas. But if you compare with Turkey, in our country, we are not as like as you are actually in your country, unfortunately. But there is a common question in our country. Let me ask my question in a simple way, as an end user, or let's say as a simple question as a farmer, because they are asking this kind of question everywhere. If I want to buy or have built a solar energy system on the roof of my house, or for generating electricity or energy from my house, or from a farm or something else, how can I be sure that I'm having or getting the right system or PV panels? How can I be sure that I'm having a good quality? I mean, are there any criteria that ensure me that I'm having a good product? Do you have any advices or any criteria that we really have to know about it? Because everywhere we go in Turkey, we are asking the same questions. Which one is better? Which one is cheaper? This kind of question we always hear around. Could you please enlighten us about these questions?
Yes, very good question. Actually, I'm not expert in photovoltaic, but if I want to answer some aspects of your question from solar thermal point of view, I can tell you that in general, according to the International Energy Association report, the levelized cost of electricity is cheaper in photovoltaic than solar thermal power. So that's why that a small portion of the energy, renewable energy, is devoted to solar thermal power. It could be useful for countries which have a high solar radiation intensity. But as far as I can see from the reports, the perspective is not so positive for solar thermal power if you want just to produce electricity. But I would like to give a comment that it is not the electricity generation that all we can get from solar power. I think we can get industrial heat, which is very, very important. Yeah. And I'm quite sure that in many countries, people can simply get industrial heat by solar thermal systems. Yeah. And this ability is not given by photovoltaic. So this is, to my opinion, a very good advantage of a solar thermal system that can give you the heat which is needed for industry.
Okay. Okay, thank you very much.
Yeah, you're welcome.
Thank you, Professor Ibrahim. If you have any other questions. If not, I think this is our last presentation. And I think no one is going to present. We had three nice.
I have a question actually, sorry. Based on this last discussion, so considering the CSP can be also used for heating, and Iran has still natural gas for heating as well. So do you still think that CSP could be used for heating in Iran, given that Iran has natural gas resources? Thank you.
Yes, in Iran, I don't think so. I don't think so. And because the natural gas is very, very cheap here. And to my opinion, in Iran, CSP will not play a main role in heating or cooling. But in other places which do not natural gas and are hot enough, I think maybe Greece and southern countries in Europe, or at least some parts of Turkey, I think we can use CSP to generate district heating, and solar cooling also will be available by CSP. So to my opinion, if I just want to give you one sentence, if you want to think on the potential of CSP, do not think on electricity production, because other methods are much more efficient and cost effective. CSP should be used for, to my opinion, industrial power, industrial heat, solar heat process, maybe used for hydrogen production, maybe used for district heating, solar cooling, or solar heating for industries, for district, and these are the applications that I can imagine.
Thank you very much.
You're welcome.
Thank you very much for a very nice explanation. Is there any other question, please? Any question, suggestion, or comment? Okay, I think there is no any other question or comment. I think we can conclude this session. And Mr. Ahmed, if you want to add anything, or if we have to do anything, I will give last chance to you. And
thank you very much.
Okay.
Yeah, thank you very much, Mr. Abdel Fattah. I think this was really interesting, and we have learned a lot more. And I'm sure the people who were watching us were happy as well with getting this kind of information. And I would like to thank you all the participants for your time spending for us and for your effort as well. And as a university, we always would like to bring all these people together and update the information about this kind of systems. And we're glad to meet you and see you here. And thank you very much. I want to thank you all. Thank you.
Thank you also. Okay. Have a nice time for all of you.
You too.
Okay. See you.
See you.